In this video, we will show you how to use Solver this time. We will start by setting up the data that we use as input to Solver. Let's say that we have the number of units in first class, economy, and cargo. And we will put just some random numbers in here. Let's say that we have 3 seats in first class, we have 4 seats in economy, and we have 14 pounds of cargo. Let's put some numbers for how many square feet each seat will take. Let's say that the first class seat takes 100 square feet. Let's say economy takes 20 square feet, and cargo, you will have to figure out how many square feet 1 pound of cargo take. Note that what you are given in the question is how many pounds per square foot you can fit. So you need to do a little bit of math here. Let's say we have 0.33 square feet per pound. Let's then add some numbers for dollars per each. So how many dollars of revenue will we generate with the first class seats? Let's say this is $400. Let's say it's $250 for first class, and let's say it's $4 per pound of cargo. With this, one more thing, let's see how much weight we have. Let's say that first class seat accounts for 670 pounds of weight. Economy would be 460 pounds of weight, and for cargo, since the number of units here is in pounds, guess what number this will be? It's 1 pound of weight per pound of cargo. Easy. Now, with this set of numbers, we can figure out what the total number of square feet would be. So that will be the sum of the number of seats multiplied by the square footage per seat for first class, for economy, and for cargo. The easiest way to do that is to use the function sum product, and we select the number of seats, we select the number of square foot coefficients, and this will calculate the total number of square feet that these numbers of seats would take. The beauty of this formula is if we change the number of seats, the total square footage gets updated automatically. We can do the same thing for the revenue, except now we will use sum product of the number of units and the revenue per seat or per unit. These are all dollars, so we can format them as dollars, and then we can use the same formula to figure out what the total weight will be. Now we are given some max values. So for example, the square footage here has to be less than, let's say, 15,000, and the total weight has to be less than 24,000. If you recall, what you are asked to do is figure out how much cargo you would be carrying if you maximize the total revenue. So in the end, we have to maximize this value in here by changing various numbers of first class seats and economy seats and pounds of weight, and you can see that these numbers will update. All the numbers here will update as we make changes to the input area. What Solver will allow us to do is maximize in a rigorous manner the revenue. So if we go to Solver, we have an objective function, and in this case our objective function will be to maximize the revenue. You can see here that it's maximized. We need to tell Solver which cells it can change. So we're going to select the input cells that we used earlier. So now we're going to try to maximize revenue by changing the number of units in first class, economy, and cargo. And we will have to add some constraints. We will see that done in the next video.